Good morning, everyone. This is your host, Shailesh Malia, and I head automation business for Veracitiz. Today, I have with me Alex Winery, Rodrigo de la Parra, and Mohammed El Sari from IBM. I start this webinar thanking you for your time for participating in this session. Time is a very important asset in our life, and we at Veracitiz are honored by your decision to spend this 1 hour with us today. Today's webinar is brought to you by Veracitiz and IBM. Veracitiz is a gold partner of IBM, and we've been in business for about 11 years for data, AI, and automation implementations. We are based out of Canada, India, UAE, and Mauritius. We implement end-to-end solutions like financial and operational performance management, forecasting, planning and budgeting, decision optimization, data warehousing, business intelligence, smart chatbots, and automation. Our customers are spread across verticals like manufacturing, banking, insurance, gaming, logistics, and retail. With automation, we specialize in observability using Instana and Turbonomics using automated workload management. We also support customers with solutions like OpenShift, WebSphere MQ, RPA, FileNet, and data capture. Let me set the agenda for today's webinar. In today's competitive world, our businesses run on diverse applications. These applications could be monolithic, SOA-based, or microservices-based applications. These are hosted on complex infrastructure, which are on-premise, hybrid, or cloud environments. To maintain edge over competition or for improving efficiency, organizations need to change. They need to adapt new business rules and policies, which in turn lead to continuous upgradation of their applications. However, with every new change in these interlinked IT applications and infrastructure, there is an inherent growth in risk of application slowdown or outages because of scarcity of resources. Organizations typically use monitoring tools to monitor infrastructure and application components. These tools get inputs from multiple agents installed on servers, which frequently run polls and send threshold-based alerts or messages. However, this is a reactive process and not good enough to manage our requirements in case of slowdown or outages. Whenever an incident occurs, it is accompanied by a number of alerts and even events in the impact area, which typically requires about 30 minutes to about 8 hours to identify and resolve the issue. If an AI-based solution is used for monitoring and observability, organizations are able to reduce these resolution times and assure best application performance. In today's webinar, we will touch these areas and showcase how AI-based automation solutions can play a vital role in helping you save time and resources. We will address these two primary areas, which are very crucial for growth in your business. What happens when your sorry about that. What happens when your business applications, especially customer-facing applications, slow down or face outages? How does your team react? Do they set up a war room and start pointing fingers at each other? How does the business react in such a scenario? What would happen if such an incident does not take place, or you are able to substantially reduce such kind of incidents? Would this help build confidence within your business and IT teams? Second is there a way to communicate to automatically scale your infrastructure based on application performance? Here, I'm not talking about AWS or GCP autoscale, which scales resources based on compute consumption. It's a good feature. However, in today's outcome-based world, latency of application benchmarks application performance. Today, Rodrigo will take us through Instana, an AI-based application performance solution, and Alex and Mohammed will take us through Turbonomics, which is an AI-based automated workload management. Each presentation is essentially an hour long, However, we've compressed it to a 20-minute session so we could present the key features and benefit. Each session will conclude with a small demo. If you are interested to know more, please message in the chat window so we could reach out to you later and do a detailed presentation for you and your team. If you have any queries during the presentation, please mention them in the chat so we could answer them towards the end of the session. Rodrigo, over to you. Thank you.
Thank you. Thank you, Shailesh. So I'm going to be covering the Instana overview, how to reduce outages and improve MTTR as you modernize IT. Now, we're all familiar with what monitor is, right? But what is the difference with observability? Observability is not a substitute for monitoring. They are complementary. Monitoring pretty much takes care of understanding the symptoms of application behaviors. But being observable means understanding the internal workings of the system, especially those complex systems that require a more granular level of understanding. Now, what problem observability solves, right? Right now on the screen, you're looking at a real small application built with microservices running on containers. And as you can see, even the small applications that are using today's technologies can have a high level of complexity, given the dependencies, given the nature of these technologies that in many cases, these containers are ephemeral, right? So it's very, very relevant to have the right tools in place to be able to observe the behavior, the dependencies, even the golden signals when it comes to practices from site reliability engineers, such as latency, traffic, error rates, and saturation. Here we see cases where traditional monitoring tools sometimes they lack full visibility, and there are blind spots where they have no ability to observe everything. So here's where having the right tool in place is critical. I like this slide because it tells you the risks for not being able to see what you're observing across a holistic view. Now let's talk about one of the one relevant KPI from observability, which is the application latency. Again, when it comes to monitoring next generation of applications running on containers and built with microservices architectures, 1 second can have a high relevancy when there are problems, when there are issues happening in the application. A recent study has found that a 1 second delay in a page load time can result in a 7% customer conversion, right? And as well as a decrease of 16% in customer satisfaction. Depending on the organization, this could translate into millions of dollars annually of lost revenue. Now, one of the capabilities that we position for Instana is the ability to automate full stack visibility, right? Being able to understand all the layers of technologies that are being implemented across an ecosystem and understand the dependencies among them and being able to see exactly their behavior, such as we can monitor and manage the golden signals when issues arise, as well as provide real-time detection and mapping all those interdependencies to reduce risk and decrease the mean time to resolve. This is critical, again, on modern applications because that 1 second latency that I was mentioning, it can have a business impact into to the revenue of the organization. Now, by providing the context and providing the ability to understand where issues happen, you can pinpoint where the issue is occurring. So, and you can take intelligent actions to resolve those issues faster, right? So this takes away, bad practices such as finger pointing on war rooms to understand where is the problem and what is the path for resolution. Here is by providing the context, provides the evidence of where the issue is happening, and then it accelerates the resolutions to tell the teams what exactly needs to be done to resolve that issue and optimize the performance of the application. Here we are looking at a map of the infrastructure within Instana that tell us the layers of technology running on each of those rectangles that are showing in the screen. We can see there are some having Docker containers or JVMs, Node.js applications. And Instana produces this as soon as we deploy the agents on the target host that we are observing. Instana only uses a single agent per host, and it pulls a number of sensors based on the technologies that is monitoring. There are sensors for Docker, sensors for Java, for Apache HTTP, for Spring Boot applications. Each of those sensors have the ability to understand the metrics for the technologies that they're monitoring, and then it provides that information to the Instana backend that allows Instana to produce dependency maps and services correlations. This is one of those dependency maps that shows how the different services are connected to each other and the traffic and flow of each of the requests in real time that are going from the front end all the way to the backend services. Instana has the ability to analyze logs and metrics, event and produce events when things go wrong, and being able to provide that context information. What is Instana differentiation? As I was talking earlier, the 1 second granularity provides that ability to understand the behavior of those services without doing any any lack of fidelity over that period of time, right? Then we have the ability to predict our pricing model is based on target host, so there is no surprises. It's pretty straightforward to calculate. We have the ability to continuously undiscover changes when deployments happened on the system, right? And we're able to understand the configuration of the applications to detect if the changes can have an impact. In the latest analysis in the industry, we are one of the main leaders for observability over cloud technologies, containers, microservices, hybrid cloud, and even traditional applications. And we provide intuitive user interfaces out of the box. And this can be customized through different ways of filtering dynamically across the areas that teams can be interested in looking into. Here is some of the customers that we help with observability across different industries. So we have a large client base across the world. Now, Instana delivers real impact to reduce the risk by providing that improved application availability. These are some of the results of our engagements by reducing, by half the mean time to resolve, 69% of mean time to detect, and 5 BPS availability for applications increase revenue in organizations by allowing them to take more automated deployments from CI/CD pipelines, increase the cloud efficiency and the cloud reduce the cloud spend, as well as their operational efficiency, letting teams focus on activities that are more valuable than just monitoring and spending hours or days finding what is the issue and having interactions with so many teams that just produce wasted efforts. So this is the theory. Let's go into the practice. Let's look into a brief demo of Instana. Now, when I open Instana, I can see on the screen, I'm going to make this bigger, an out-of-the-box dashboard that provides me a summary of the different sections, such as websites and mobile applications. Here, right off the bat, I can see the rates of how many sessions are being right now happening on the mobile applications, how many views, and the rate of those. This is from an end user monitoring perspective. But from an application perspective, being able to understand the dependency of the services that are supporting the application, I can see here the golden signals that I was talking about, right? The latency on the calls, the number of calls, the saturation, the error call rate. And I can determine whether there could be a problem or not in my application. There is also the infrastructure view. There is something wrong here in my AWS demo. I can see right away, and I can dig into that, but we'll go into that in a second. We have the ability to monitor different platforms, such as Cloud Foundry, IBM Power, Kubernetes, OpenShift, and so forth. And then at the bottom, we can see the rate of events, which ones are, in this time frame happening across all the applications that I'm observing. So let's start by taking a look at the infrastructure. This is a very nice view of my landscape of infrastructure view of where my applications are running. Across, I can categorize this by technology, by location, and so forth. There are different views. This is actually by zone. So I can drill down and start looking into these elements and identify what is running on each. So let's take a look at this one. So this is like a building with different floors, telling me what processes and technologies are running. An Nginx server running here, and for each of these, Instana produces an out-of-the-box dashboard. So you don't have to produce the dashboard for them. I can see here that Nginx server, the services that is running, processes, and so forth, that helps me understand the different metadata versions that, for example, what version of Java is running, what environment variables are being used, and so forth. It could also tell me the status, right? Yellow means that there is something here that is a warning. So there is an issue of frequent TCP fails that I can take a look and see what is the impact on my application. If I zoom out, I see here one that is in red, but it's telling me that there is a device on the system that is full, so that's gonna cause issues, and I had to take a look into that. Let's take a look at the end user monitoring. So, for example, if I open one application, I can see in the period of time or the time frame that I selected, in this case from 4:30 to 4:31, but let's actually expand this to the last 6 hours. So this allows me to determine the time frame. I can also look into the releases of the applications that are being deployed. So This tells me that there was one release that may have, if I see a higher number of JavaScript errors, this release that happens at 450 may have caused issues. In this case, it doesn't seem like, seems there are more issues towards the 1020 mark. I could also see the geographical location of the page loads that are being requested on this website, as well as the top JavaScript errors. So this is one that is interesting because it can also tell me how many affected users are being impacted by these JavaScript errors. I can drill down into what browsers they were using, what operating systems they were using, and so forth. Let's go back to there are different tabs here that I can navigate to understand the speed of the page loads and other things that are interesting. Let's take a look at another view that is called the applications view. This is more from a dependency of services perspective, where let's take a look at the same application, but not from an end user perspective, more from an internal architecture perspective, where I can see how the behavior of the golden signals are happening, right? So again, in the same time frame, I can see there is a low percentage of erroneous calls. How many calls are occurring 70 per second, the mean latency, and so forth. I can also see here the top services. The dispatch seems to be taking quite a long time. So we'll look into that in a second of why is that happening. Now, one view that is nice is this one, the dependencies across the different services of the application. And here it tells me where the flow is happening, right? And I can see some red dots here that the discount service is having problems right here, right? Also, I can expand. Let's actually refresh this view because I'm missing some of the out of the box options. There you go. So max erroneous call rates. This will increase the size of the bubble when there is more issues. So the discount here we can see there is a lot of issues happening on the JDBC connection into the backend database, right? 100% of erroneous calls. So this is a problem. We'll look into that. There is also a services list that allows me to analyze specific technologies or services. So if I want to take a look at, let's see, all the JVMs that are in the system, I can see the golden signals across them, right? They seems to be in good health, so that's fine. All right, so let's go back to the summary. And these dispatch services, let's dig into this one. So there is some erroneous calls here. Let's actually increase this. Let's decrease to the last hour. Now, if I analyze this, let's actually do a filter here on the discount service. There you go. There's some specify calls here that are providing errors. So let's drill down into this. This is one of the capabilities of Instana to be able to trace down errors that are happening in transactions, right? So I'm looking at one specific payment post call on the same application that we were looking at. Here we can see the timeline. This is for a 3-second time frame and the different processes that are being called, right? But there is a problem here. We'll look into that. But I can also see the view of the calls on the transaction. So there is a post call here that calls another one, and then it requests a get of a resource and so forth. But there, here's the same problem that I see above. There is a problem here in the put. But scrolling down, I can also see the service endpoints and the latency on those. So let's click on this one. And on the right side, I can see the details of the request path, the URL, and the error message. So here is the error which is pretty much a timeout, right? That is happening in the system. Some of the context that I get is the profiling of the application, where the Java processes are taking most of the time, the infrastructure view, and where is the destination of that service. So this allows me to understand where things are breaking, and then I can take action into those, right? Let's see, we can also have the ability to analyze logs into the application. Let's take a look at, let's see if we find another one. Since this is a live system, sometimes we see different error calls. So here I'm gonna go into view and analyze and see what's happening. So let's take a look at, for example, the payment service. Actually, let's take a look at the ratings instead. Try to find one that is caused by the JDBC connection. Okay, this is a different one, but one thing that I wanted to show as well is that we have the ability to analyze the stack trace in the source code. So I can open the source code. This is huge for developers, and point out what exactly the error is manifesting. And all the stack trace calls of this application this is in Spring Boot. So as you can see, out of the box, Instana provides you that ability to understand the behavior of applications. You can analyze errors as they happen, including logs, and correlate those to provide more context and being able to determine the problem, and therefore reduce the mean time to resolve the issues. With that, I conclude the Instana topic.
Thanks, Rodrigo, for that great presentation. You all saw the observability that Instana provides. And now we'll move into application resource management and how IBM Turbonomics provides that to assure application performance. So I'll touch on the challenge that Turbonomics solves and how it does so and solves that problem. So when we speak with our customers prior to them leveraging Turbonomics, they've typically described a similar challenge with managing the modern application in the modern stack. We've got all these various layers from your network, your infrastructure, on-prem, and cloud, virtualization, with your cloud ops team, containers if you have a container strategy, your APMs, and up top to that modern application. In the traditional way that we've seen this managed is we have these teams at each one of these layers, each with their own tools that are great at monitoring the health of that specific layer. They have different polling rates, thresholds, KPIs, dashboards for that layer. So that leads all of these teams to have different and disparate data sets. And these tools tend to look at bottom-up performance of this stack. And where the problem is really accentuated is when that performance alert does come in, when that manually set threshold gets crossed, an alert is triggered. You probably get many of these alerts on a daily or weekly basis. And when that alert comes through to all of these teams, each of these teams across your infrastructure have to go to their tool. They have to look at the health of their layer. They've got to confirm whether or not the problem is there in the stressful IT war room. There could be a lot of finger pointing. There could be a lot of blame, and it takes your best IT professionals into a reactive state where they need to troubleshoot instead of focusing on strategic initiatives. And hopefully that problem is found within one of these layers quickly, but then you still have to manually execute that action. You have to verify that you're taking the right action, and that it's not going to accidentally impact something else in this very complex and interdependent state. And then you just have to hope that you don't get put back into this cycle for as long as possible. And so do we ever risk performance? Absolutely not, because the most critical task of IT, we could all agree, is assuring application performance and how critical that end user experience is. And we know how many negative impacts a bad end user experience can cause. So we try to never let that risk impact it. But in this reactive state, we're allowing that risk to enter the environment and then taking these actions to try to fix it and push it out of the environment and get back to that optimal state. So instead of that model, what if you could only pay for what you need based exactly on application demand instead of ever over provisioning resources in hopes of assuring performance? But what if we could prevent those performance issues before they ever impact that end user experience? What if you could close the operational gaps between the app and infrastructure teams in that complex stack by mapping out that entire environment? And you could achieve cloud elasticity at scale with automation, allowing software to give you these resourcing decisions. And if you did that, you'd have continuous performance in real time, continuous automation, and truly be able to unleash elasticity, because Turbonomic could continuously automate application resourcing. And you can see exactly how that improves end user experience. So you see a customer quote here on the left. It's just highlighting how organizations have so many of these different tools, cloud native tools, infrastructure tools, but to actually get that action to take to assure performance is where the problem comes in. And humans are not sustainable for this kind of optimization where you have to sift through all these different recommendations. It requires a platform that can give you the exact action to take in real time, which is what Turbonomic can do. So how Turbonomic does that is it bridges the gap between those who write and develop the applications and those that host them. And Turbonomic bridges this gap by mapping out your entire environment into what you see here, what we call our supply chain here in this diagram. This is done using API-driven discovery of your targeted environment. You can see that we could target applications using APMs like Instana, Kubernetes, AWS, Azure, GCP. It's a hybrid and multi-cloud platform. And in this view, it's that holistic app-centric view that I spoke about earlier. You can see the downward point arrow showing how Turbonomic views your entire stack through the lens of the most important thing in IT, which is the application. And it shows the relationship of all of these different entities throughout your environment and how they impact one another. You've got your applications, transactions, services up top, pulled in from your Instana integration, your container infrastructure, VMs, this can be on-prem or in the cloud, down through different layers of your infrastructure, and then even out to the zones and the regions in the cloud. And you see the health associated with each of these entities as well. Green is that desired state of performance, cost, and compliance that Turbonomic will push your global environment to, and then continuously keep it there. Yellow are efficiency opportunities in the cloud, or this could be over provisioning risks on-prem that could lead to things like ready queue and ballooning and swapping. And then red are those critical performance bottlenecks, where that entity doesn't have the resources it needs to be able to support application performance. And once Turbonomic quickly maps out your environment and understands all of these relationships amongst all of these entities, it'll begin providing trustworthy actions in real time at every layer of the stack based on all of the resources that the application requires, as that demand constantly fluctuates upon the application. Sizing, placement, scaling, start-stop actions. And these actions can then be easily executed manually with a click from the Turbonomic interface, scheduled in an existing maintenance window, or taken in real time with dynamic automation policies that are very easy to configure based on your business policies. And when this is done, we see improvements in app performance. We see reductions in infrastructure and public cloud spend because you're only provisioning exactly what that application demands. And we see increases in team productivity because we're no longer troubleshooting performance issues. We're preventing them with these actions that Turbonomic continuously provides throughout your infrastructure. And as Turbonomic continuously optimizes your environment, you can see the impact it has directly on that end user experience by seeing application response time and transaction throughput metrics pulled in from integrations with APMs like Instana. So here in the screen, you see a unique scope view within Turbonomic that allows you to scope into a single application. You can do this with various other entities as well throughout the infrastructure. But in this case, we're scoped into a single application. And we see here this smaller version of the supply chain, which are the specific group of entities that support the performance of that application. and then we see the health and the actions associated with each of these. Turbonomics infrastructure actions are tied to the performance of this application and user experience, which builds that trust across your organization. This application awareness allows your organization to safely take these actions at scale to assure performance and allow your team to automate them and increase infrastructure utilization. And here's just a quick case study. Turbonomic has customers across all different industries. In this case, this is a large energy company. See some of the challenges they faced here, have experienced application performance issues due to resource congestions. They were moving to Azure and they were doing best guess scenarios on the resource requirements, which led to that costly over provisioning. And then they had those manual processes. Think of that reactive cycle that I spoke about earlier, where they were monitoring thresholds to identify any application performance issues. But upon deploying Turbonomic and targeting their 6,000 plus workloads across their Azure and VMware environment, they saw a 95% reduction in application performance issues just due to Turbonomic's placement automation. They saw 124,000 savings per month due to SQL optimization and $430,000 savings per month via storage reclamation, because Turbonomic is provisioning the exact amount of resources needed in real time and over time. And lastly, so Turbonomic has a no-cost proof of value, deploys very easily as SaaS, and within an hour of targeting your environment, your infrastructure supply chain is mapped out and the resourcing actions will begin to be provided. The POV typically runs for about 30 days, and at the end of the process, the team will evaluate the impact Turbonomic can have, such as the return on investment and application performance improvement, all from the data from your environment, leveraging that POV. So that was a high-level overview of Turbonomic and the problem it solves and how the real-time application resource management assures performance at the lowest possible cost.
Hey everyone, Mohammed El Sharif here, enterprise engineer at Turbonomic. And just to add that visual to what Alex was talking about, this is really the Turbonomic UI, and we can be up and running in any environment within 30 minutes to 1 hour. As Alex mentioned, everything about Turbonomic is API driven, so there's no need to configure any agents on any of your devices or workloads. As long as we have the correct service accounts or IAM users, service principals with the correct permissions, we can start discovering your estates and building this supply chain. So in this supply chain, we get your business level application data, business transactions, service and application level component from your APM tools like Instana, AppDynamics, Dynatrace, New Relic. We get your Kubernetes level data from your Kubernetes deployments like AKS, EKS, GKE, OpenShift. And we get your virtual machine level data, database servers, storage, and physical host level data from your hypervisors like vCenter, Hyper-V, Nutanix, Hyperflex, as well as your hyperscalers like AWS, Azure, and GCP. And we stitch all of that data together to give you that single pane of glass view from your top level business application all the way to the underlying infrastructure that services this application. And when I hit here that on-prem tab, you can see how my supply chain changed to reflect my on-premise state. And when I hit cloud, you can see as well how the supply chain changed to reflect your cloud estate. And because Turbonomic understands the relationship between every single entity here in the supply chain, and not just from the top level or to the bottom, so not just in a vertical sense, but also even across the stack, it's able to provide us with these specific actions and recommendations regarding scaling decisions, so scaling up and down your virtual machines, your volumes, database servers, start by actions, which are decisions around RI purchases on the cloud or provisioning and suspending hosts on-prem, placement actions, which are moving VMs from one host to another, or moving pods in a container environment from one node to another. Configuration actions, which are actions that are revolving around your compliance and governance, and the delete actions, which are actions where you can delete unattached storage volume and save money, or unattached or unwasted storage files. And this is just from the top level showing me all of my infrastructure and all of my in my estate. So if I choose one application and all of this gets built automatically, there is no manual intervention here. You can see that when I clicked on just the one business application that we're discovering, you can see how the supply chain changed to reflect this one business application having 7 transactions, 11 services, running on top of 4 virtual machines being serviced by 2 data stores and 2 physical hosts. And you can see how we're getting the response time data of the application from the APM as well as the transactions per second. And Turbonomic is all about preventing risk in the environment. And this risk is identified by these colors, as you can see here at every level of that stack, where green for us means that you're provisioned correctly and there's nothing or no risk that that needs attention. Yellow is an efficiency risk, where Turbonomic sees that you're actually over provisioned and you can safely scale down while assuring performance and reclaim resources on-prem or save money on the cloud. Red for us, which is our most critical risk, which is a performance impacting risk. And this is where Turbonomics sees that you're actually under provisioned and you need to scale up in order to prevent congestions and degradations in your application. And these risks now and these colors are reflected by these decisions. We can see that for just this one application, we have 76 actions that have a direct impact on this application. And when we hit the show all button here, we can see all of the actions on which entities have an impact on this application. So we can see that we are having move actions, so moving VMs from one host to another to prevent congestions, prevent degradations, for performance, so preventing ready queue and CPU congestion. We also see decisions on delete, so delete files that haven't been used or accessed in a while in order to save or reclaim more space. Resizing decisions, so, and in this case, we can see Turbonomic has identified that 3 of the 4 virtual machines running the application have a risk on memory. In this case, Turbo is recommending to scale up from 512 megs to 1.5 gigs in order to, again, prevent congestions, and it's a performance decision. So this is just for one application. You can see that we have 76 actions for one application. So if I actually zoom out again and go to that main screen, and this is a demo environment where I only have 56 applications running on top of like 1,000 virtual machines, you can see that the number of decisions increases exponentially to over 3,900, which really makes it very difficult, if not impossible, for humans to manage this at scale in real time and continuously. And this is really why you would need software in order to help you, at least from an infrastructure perspective, make sure that your applications are getting the resources they need when they need it, and when they don't, we can just take them away. And here on the left-hand side, you can see all of the entities that we're discovering and making decisions on, and what type of actions. And if I scope to any of these entities by just clicking on the buttons here and checking, and as long as I have, again, the right permissions, we can execute the actions manually through Turbonomic. And once we're confident and comfortable with these decisions, we can then start to automate and have Turbonomic automatically execute those decisions during a maintenance window or an outage window, as well as integrating with your change management processes like ServiceNow or CI/CD pipelines like Ansible or Terraform, so that the Turbonomic execution becomes part of an existing process instead of building a new process around it. And just looking at some of the cloud decisions here, I can either go on-prem and see all the decisions that have an impact on my on-prem state. And when I hit cloud, you can see all the decisions that have an impact on my cloud estate. So if we just deep dive into one of them here, Turbonomic identifies this instance. It's running on AWS in this account. This is the current template or SKU that it's running on, M54X large. It is not covered by an RI, so we are RI aware. And all of the decisions that we make take your RI inventory and RI utilization into consideration. And we're looking always to maximize your RI utilization because it's an investment that you made, so we don't want you wasting that investment. So in this case, this instance is not covered by an RI, and we understand the on-demand cost of $0.7 an hour. So Turbo's recommending that we go to an R5 2X large, no RI coverage, and it's going to bring down your on-demand rate to 0.45, so saving you $230 a month in this case. So when we click on details now, this is where we can see why is Turbonomic giving us this recommendation. And you can see that it's giving us this recommendation because of underutilized vCPU and net throughput. And by default, Turbonomic is always looking at the past 30 days of data at the 95th percentile. So basically where you're operating at or below 95% of the time. And we understand that not all your applications are the same and not all of your environments are the same. So we have the ability to tweak this through policies to be more conservative when it comes to production workloads, for example, or more aggressive when it comes to dev and testing workloads. So if we look here in this chart for CPU utilization, based on the data that Turbonomic is collecting, it notices that your daily average utilization has been around that 8%, 7.98% utilization. However, based on the Turbonomic algorithm, we can see that the utilization is at 14%, which clearly shows here that Turbonomic is not just taking your average utilization into perspective, but also your peak utilization in making its decisions. And it's able to then also tell you that if you take that action, you're going to move from a 14% utilization to a 27.7% based on understanding the workload. So it's able to actually project when you take that scale down decision, what would be the projected utilization. And we're making the decisions not just based on one metric at a time, but we're actually looking at all of these metrics: CPU, memory, net throughput, VM storage, and we understand your uptime. So we're taking all these metrics into consideration when making that decision. And we're telling you exactly where you need to go to and what would be the cost and the savings associated with that. And then just the last piece I wanted to touch on is the planning feature. So we definitely understand that out of the gate, you will not be making those decisions, and you actually want to understand the impact of these decisions on your environment. So with our planning feature, we have the ability to run a simulation on what we refer to as that real-time market that will tell you if you take all the decisions on cloud or all the decision on-prem or even a subset of those decisions, what would be the impact of that on your environment? As well as we have the ability to run migrate to cloud plans, which will tell you based on your on-prem workloads, if you do a lift and shift as is to the cloud, what's the compute family, what's the storage family, and the cost associated with that, compared to if you actually take the Turbonomic decisions and optimize and then move it to the cloud, what would be the compute SKUs, the storage SKUs, and the cost associated with that. Shailesh, that brings me just to the end of my demo. It's keeping it high level.
Yeah.
I'm sending it back to you. Thank you.
Thank you, Mohammed. That was a detailed one. And I'm sure 10 minutes would be a very short time to cover both Instana and Turbonomic demos. So I'm open for questions now. If you have any questions, participants could mention it in the chat, and Alex, Mohammed, and Rodrigo could answer them. Okay, so I think there are no questions right now. However, we'll be reaching out to the customers over a period of time. We'll share the presentations of videos.